Hi, this is Empowering Introductory Algebra, the series created to assist students to overcome any basic algebra deficiencies and build a strong foundation leading to college-level studies. I'm Bob Young, Assistant Professor of Mathematics at Brevard Community College. With the help of John, Mike, Wendy, and Dave of WBCC, we will bring you introductory algebra lessons like no other. Let's pick it up where we left off, and we'll show you why. To begin today, we're going to start with some study tips, because not only do we want you to know the how and whys of algebra, we want you to become good students. And remember, practicing math is not like some other subjects, so let's look at some graphics starting out created by my friend Mike here. And the first graphic is, when you work through problems, make sure you copy the problems, even ones you see as easy enough to do in your head. For example, even a basic inequality problem, which we're going to talk more about today, -2 is less than 5, tells a lot more than a bunch of less thans, greater thans, less thans on your homework when you review for your test or final exam. So copying the problems, very important. In the next graphic, show steps in detail. Write each step as you work through the problem. If you go the wrong direction, your instructor or tutor will be better able to assist you. And remember this is huge. A lot of mistakes in math will reoccur if not corrected. And boy, I bet you some of you found that out with the signs here in the previous lessons. And the final study tip we're going to talk about today before getting into the lessons is make sure you ask questions when material is not understood. Instructors aren't mind readers. It is not a sign of weakness to ask questions, but a strength. There may be others with the same question too shy to ask. So assert yourself. You're paying good money for these courses. Let's make sure you get the maximum out of them. Now, going to the lessons, we're going to begin today with solving algebraic equations. And the equations we're going to talk about are linear equations, and we're going to find later that those lead to lines. And these are accomplished solving these equations with two major properties, the first being the addition property of equality, which says if A equals B, then A plus C equals B plus C. Or if A equals B, then A minus C equals B minus C. Why is the use of subtraction classified under the addition property of equality? Well, let's look at some examples and we'll show you. So for example here, if we have 5 equals 5, which I think we all know is a true equation, the addition property of equality says, well, what if I go adding 2 to this side of the equation? Not the same anymore. So what we're going to do is whenever we add something to one side, we can add something to both sides. So that's where the addition property gets its name. Now, let's come down here and take another true equation, 8 equals 8. Now, why is -2, if I subtract 2 from both sides of this equation, why is that called the addition property, Young? Some students are confused by that and not the subtraction property. Well, remember in previous lessons, we talked about the definition of subtraction. And the definition of subtraction said that you can write anything A minus B as A plus A negative B. So subtraction can be rewritten as addition. So therefore, they call the use of subtraction here 8 minus 2. They could write that as 8 plus -2, adding a -2 to both sides of the equation. So the addition property really holds for both addition and subtraction. Now for the next graphic, we're going to talk about the multiplication property of equality. And the example here is if A equals B, then A times C, and remember that's written AC, equals B times C, BC. Or if A equals B, then A divided by C equals B divided by C. Now, why is the use of division classified under the multiplication property of equality? Well, let's take a look. So going back to some examples, 8 equals 8 using the multiplication property. If I go multiplying this side of the equation by 3, to keep it balanced, I must multiply both sides by 3. Or let's say I have 10 equals 10. If I divide both sides by 2, why do they call this the multiplication property, Young? Well, remember there's a definition for division as well we have learned in previous lessons. And the definition of division says if you have any two things in terms of division, you can rewrite that in terms of multiplication by multiplying by the reciprocal of the second item. So A divided by B can also be rewritten in terms of multiplication as A times 1 over B. So dividing both sides by 2 would be equivalent to multiplying both sides by 1/2 or the reciprocal of 2. Therefore, these go hand in hand. So the two properties we're going to talk about, the addition property, addition and subtraction are included. The multiplication property, multiplication and division are included in that. Okay, continuing on the graphics here. Solving algebraic equations, remember that whenever you solve algebraic equations, use the BS rule. Now, you high school and middle school teachers out there, do not go into an algebra class and ask the students what BS means in algebra. They might tell you, but really there is a rule for BS that I like to use, and that is whatever you do to one side of something equal, do to both sides. Let's look at some examples with numerical equations. Okay, so we have, for example here, 9 plus 3 equals 12. So if I go adding 3 to this side of the equation, I must add 3 to both sides. Therefore, the BS rule is in effect. If I have 8 minus 2 equals 10 here, if I go subtracting 4 from this side, BS, subtract 4 from this side. So make sure whatever you do to one side, this equal sign is like a dividing line here. Whatever you do to one side, you do to both sides so you can justify. All right? Now moving along here, this is a huge concept I see a lot of students make mistakes on. 8 times 5 is 40. Let's use the multiplication property here. Let's go ahead and multiply both sides by 2. And that makes sense because if we did our order of operations here, 8 times 5, Aunt Sally would say from previous lessons, do in the parentheses first. This would be 40 times 2 would give us 80 on this side. Multiplying here, we would have 80 on this side. But notice, do not distribute the 2 through multiplication. That distributive property we talked about in earlier episodes, you can only distribute through addition and subtraction, and I'll show you right in this example why. Now let's multiply both sides by 2 here. Okay. Now Aunt Sally would say, go ahead and do the parentheses first here. 6 plus 4 is 10 times 2 is what? 20 equals 20 here. So that makes sense. But notice I could also distribute the 2 through the parentheses here, writing it as 2 times 6 plus 2 times 4. Now, Aunt Sally here, order of operations, would say do the multiplications first. So 6 times 2 would give us 12, plus 2 times 4 would give us 8, and that would give us the 20. So remember, when you distribute, you can distribute across addition and subtraction. Do not try to distribute. Do you see up here, if I tried to distribute that 2 across multiplication, I wouldn't end up with the same thing. So I might have to put the there. All right? And down here, across addition, subtraction, good. Good. All right, now continuing here, when you solve, let me get straightened up here a little bit. When you solve linear equations, we're going to use what is called inverse operation plus the old BS rule, which stands for both sides. So remember, in math, there's some certain operators. The operation for addition, what undoes addition, its inverse is subtraction, and vice versa. If I say the operation is subtraction, the inverse of subtraction, what undoes it, is addition. Multiplication, division's its inverse, and division, multiplication. All right, so each operation in math has an inverse. When you go to solve these equations, and you're going to use the both sides rule that work in unison together. Okay, so we'll go back to a graphic here, continuing. And our first example, with variables in the mix, nothing changes. All right, an example, x plus 9 equals negative 11. To solve for x, undo addition by subtracting 9 from both sides. BS. So let's look at the steps now. All right, so up top here, we've got x plus 9 equals 11. So what this says is some number added to 9 is going to give me a negative 11. So if I want to isolate this variable, which is what I'm after, to take out plus 9, I'm going to go ahead and subtract 9 here because that will take the 9's out. But remember, these are equal things starting out. Whatever you do to one, you must do to both sides. So now we can tie in some sign rules from previous examples. We will get x equals negative 9, or I'm sorry, negative 11, subtract 9. We can use our addition subtraction rules here. Same signs, add the two numbers, put that sign in your answer. So the answer for x will be negative 20. Now, you know what I like about equations is that you can take this answer, physically substitute it up here, and it will make perfect sense when you go to check it. So this is called the solution of this equation. It can be checked and it will make sense. So if I put negative 20 up here for x, substituting it back in, and I add 9, notice I do get negative 11. It does check. And I guess we can go back to the smiley face there. Now let's say you messed up. Let's say you came up with positive 20 instead of negative 20 here. You made a sign error. If I were to put positive 20 up here, 20 plus 9, that sure isn't going to give me a negative 11, so I would know to go back and rethink this. All right, so to attack addition, use its inverse subtraction, both sides. Okay, on the next graphic, well, then Young, how do I attack subtraction? Here's a subtraction example. X minus 12 equals negative 5. To solve for x, undo subtraction by adding 12 to both sides of the equation. And notice I throw the BS in there. And some of you who have watched some of these shows will know there's a lot of BS going on as Young keeps on teaching here. All right, so let's demonstrate this sign rule. Let's go back to the illustrations here. We've got x minus 12 equals negative 5. So to take that subtraction out, go ahead and add 12 to both sides. So again, we are trying to get that variable by itself. X equals, here's our addition subtraction rules, negative 5 plus 12, different signs, subtract the two numbers, and we get 7. What kind of 7? Positive, sign of the larger number. All right, so those sign rules will continue to be important as we solve these linear algebraic equations. Take 7, plug it back in, it'll make sense. 7 minus 12 equals negative 5, you betcha. You betcha. It fits like a glove. It is the only number in the universe that satisfies that equation. I like the way that rolls off the tongue. Satisfies that equation. And you know, if that's not right, I kind of got a song in my mind here. If you get the wrong number and you plug it in, you know what you could start singing? I can't get no boom, 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 satisfaction, boom, boom, boom. It won't work. So just keep that in mind. All right, next example. Let's go to the graphics. What about multiplication, Young? In this example, we've got negative 3y equals 24. So to solve for x, undo multiplication by dividing both sides of the equation by negative 3. And let's go back to the examples here and look at this one. Now, a lot of students I see that make mistakes, they'll go ahead and they'll try to add 3 to this to solve for y. They'll add 3 to both sides, but see, they don't understand what a negative 3 and y mean back to back. This means negative 3 times what number gives me 24. So the inverse operation of multiplication is division. So we want to go ahead and divide both sides by negative 3. And why a negative 3? Because we want to come out with a positive variable here. A positive 1y. Now, you know why they don't write the 1? It's the hidden one there, but that just means 1y equals, when you divide a positive by a negative from previous lessons, you get a negative 8. All right, so division takes out multiplication. Plugging the negative 8 back in makes perfect sense. Negative 3 times negative 8 gives us, you betcha, positive 24. So I like equations, they make sense. Back to the graphics. All right, so one more creature to conquer here. Young, how do I attack division? So I've got a negative fraction here, a over 5, which you should remember means a divided by 5 equals negative 30. So to solve for a, undo division by multiplying both sides of the equation by 5. So let's look at this real quick. Now there's something else I want to make a point on here. This negative bothers students in front here, this negative a over 5. Now did you know there's 3 different ways you can write a negative fraction? You can put the negative on the top with the a. You could put the negative out front like the problem is written, or you can put the negative on the 5. But the thing is, you don't want to have 2 negatives. That's bad syntax, because if you had 2 negatives, let's say we had a negative a over a negative 5, well, we know a negative divided by a negative, that would become a positive fraction there. See, so 3 different ways to write it. Where should we put this negative sign here if we're after a? Well, I think the best place is to go ahead and put it in the denominator of the fraction. So that way we'll have a isolated by itself. So now to take out, divide negative 5, we're going to go ahead and multiply both sides by negative 5. And if you want to, you can put a 1 under the negative 5. So you can, from previous lessons, cross-cancel or chop the negative 5s out. All right, so those will cancel out, leaving you with a equals a negative times a negative is a positive 150 for the solution. And that will, again, check if you put it back up there and check it. Okay, so I hope we're getting a good understanding. I hope we're getting a good feel for getting these equations taken care of. So to attack addition, subtraction, subtraction, addition, multiplication, division, and vice versa. Those inverse operations with a little BS on the side. Make sure that whatever you do to one side, you do to both sides. All right, let's go back to some mixed practice now and see if we can hammer these concepts home. So I have gone ahead and taken the liberty of mixing these up here. So we'll start with this first equation, y minus 9 equals negative 8. To take out a minus 9, attack it with addition, plus 9. Y then equals negative 8 plus 9, different sign, subtract, sign of the larger number, positive 1. Fractions, you ask? Yes. If we're going to go ahead and isolate x here to take out plus 2/3, add 2/3, we'll subtract 2/3 from both sides. Now, in this case, we need to get a common denominator again, so the rules do not change. It's not always the algebra that hurts students. Sometimes it's those basic skills involved that hurt. So we have to go ahead and get a common denominator. In this case, will be 9 to match these up. Negative 2/3 multiplying top and bottom by 3 becomes a negative 6/9. So what I have is a negative 5/9 plus a negative 6/9 gives me what? X equals negative 11/9. And now where do we want to put that negative? At this point, I don't care. Out front, top, bottom, you name it, it's going to be the same. All right, continuing. 6y equals negative 3/5. That's not a point there. That's something that got in the way. That's just a 3/5. Divide both sides by 6 to undo the multiplication here. Now, this one's going to look kind of strange to y'all. You're going to say, wait a minute, Young, how do I take this and divide it by this? Now, let's write it a little different way. It might help us to see it. We can take negative 3/5 divided by 6, if it helps you, and write it the old-fashioned way. How about that? And remember, you can't divide fractions. That definition of division we talked about is the first number stays the same, multiplied by the reciprocal of the 6, which is 1/6, and then you can go ahead and solve. So here we have a cross cancellation, or chop is there, so we can say 3 goes into 6, cross cancels twice, and we end up with a negative 1 over 10. So the answer there would be negative 1/10, multiplying. Okay, so basic skill still in effect. All right, moving to the top of the page here, we have also a fraction here. I find fractions and decimals bother students a lot, so I try to emphasize those basic skills as you're building here. This states negative 3/4 times what number gives me a negative 12? Negative 3/4 times what gives me a negative 12? Attack again, multiplication with division. But at this point, you might start getting smart and say, well, Young, I'm not going to keep dividing by this fraction because I know I can't divide fractions. So you might get smart at this point and say, I'm just going to go ahead and multiply by the reciprocal of a negative 3/4, which is a negative 4/3. And if you do it to one side of the equation, BS, do it to both sides. Okay, so we have a negative 12 times a negative 4/3. Remember, this is the property of inverse for multiplication we talked about last time. Any number times its reciprocal is 1, so we end up with 1x equals, we can put a 1 under the 12. Yes, Young's got the chopper set up. 3 goes into 3 once and into 12 4 times, and we end up with a positive 16 for the answer. So x would equal 16 there. And some decimals for your viewing pleasure. All right, now this time I put the variable on the right-hand side. Does that scare anyone? Are you at home going, oh, no, don't put it over there, Young? That doesn't matter. We just want to isolate this x by itself. So to take out the subtract 9.6, we're going to go ahead and add it to both sides. So it doesn't matter which side of the equation x is on. Don't panic. Okay, so in this case, we have 9.6 positive here added to a negative 7.6. Different sign, subtract. Sign of the larger number here is going to come out a positive 2. So remember those same signs and different signs rule. Okay. Let's step it up a notch. Solving linear equations. Now again, on empowering introductory algebra, we just don't take the easy ones. We go after some of the more difficult problems as well and line them up here. So let's look at some of these. Now, fractions and fractions, oh, they scare students, but if you remember, whenever you've got a fraction here and you're dividing to solve, you'd have to divide both sides by a negative 3/2. Again, multiply by the reciprocal to solve for r, which is a negative 2/3. And if you do it to one side, both sides. Yes. All right, so you can see then that this times the reciprocal gives us r equals negative times a negative is going to be positive, and I've got some chopping action going on here. So we've got 3 goes into 3 once, into 27 9 times. 2 goes into itself once and into 4 twice. And that gives us r is a nice positive 9/2. Next example. Now these are stepping it up a notch as it says up top there. Here, if we're solving for x, we've got 4 times what number? Subtract 6 gives us a negative 18. So here we're going to have to do several steps to get the answer. First, I want to try to get this x by itself, so I'm going to get rid of the minus 6 by adding 6 to both sides. So what that's going to leave me is 4x equals a negative 12. Different sign, subtract sign of the larger number. And now, 4 times what gives me negative 12? Well, to undo the multiplication, we're going to attack it with division. And we'll bring it over here on the side. That gives us x equals negative 3 as a final answer. So again, even when they get more complicated, to take out subtraction, attack with its inverse, addition, both sides. To take out multiplication, attack with its inverse, division, both sides. And then when you get that answer, you can plug it in up here and it'll check and make perfect sense. So if I take 4 times what we got for x over here, negative 3, that's negative 12, subtract 6, gives me negative 18. That answer makes perfect sense. And if it doesn't, you know you did something wrong. So these are checkable creatures. You can never miss one of these on the test if you're careful. And you know where most people will tend to miss one of these? I'll circle it. The culprit in algebra, those sign errors, and that's the thing you have to work on your signs about. If you get those straight, you're going to be in great shape. All right, last example on this page here. Here, do you recognize something from the past? We have a negative 6y plus 3y. We have to collect like terms here. We have to put these terms together, and again, that's using your addition, subtraction, sign rules. Different signs, subtract the smaller number from the larger number. Put the sign of the larger number in your answer. So we end up with negative 3y equals negative 24. To solve for y, take out multiplication by attacking it with division, and we end up with y as being a positive 8. All right, so continuing on here, now I'm going to even try to make it a little more difficult, empowering linear equations. So we're to the point now, if you can do one like this, you can do any of them. You will be sitting there giving the thumbs up, be going, yes, I can feel the power surging if you can solve these type of equations for x. So what we're going to do is we have x's on opposite sides of the equal sign now. So what we have to do is get them together by collecting like terms. And I'm going to kind of do this one two different ways. I'm going to bring the 2x to the left first by subtracting it from both sides. So let me go ahead and make an arrow here to show that. I'm going to bring the 2x over, and what takes it out? Well, subtracting it, it's inverse. That goes bye-bye. And then we end up with a positive 4x minus 7 equals 21. And it's similar to the last example we did. So if we want to isolate x here, first we'll get rid of this negative 7, or subtract 7, by adding 7, its inverse, leaving us with 4x equals 28. And 4x means 4 times what is 28? We all know it's 7, but we'll show the steps because we don't skip steps on this program. X equals 7 for the answer there. So I took the letters and put them on the left. So sometimes I'll go ahead on my rainbow there and put LL. So LL means letters left. All right? And the minus 7 I took and put over here by adding 7. And I'm going to go ahead and maybe entitle that NR. That means take the numbers right. So I'm taking letters left and numbers right. It doesn't matter which direction you take the letters or numbers. I could have taken the letters to the right and the numbers to the left, but this is just a habit I like to use right here, is go ahead and letters left and numbers right. All right, so we're going to go ahead and wrap it up here by doing a few more examples here. And some of you are going, oh my gosh, they're getting larger, these equations. Yes, and they're just more fun when they're larger. So again, we're going to go ahead and put these together by collecting like terms on the left and right hand side. So we've got 6y, negative 4 plus 9 is a plus 5, equals 12, and negative 8 plus 1y, different sign subtract, gives me a minus 7y. So remember, there is a 1 in front of this y right here. Okay, so again, we're back to that same scenario as last example, letters left, numbers right. So I'm going to go ahead and add 7y to get the letters on the left-hand side. Then I'm going to go ahead, I'll make a little LL for you at home. All right, the numbers I'm going to go ahead and take right by subtracting 5. And that's going to leave me with 13y on the left-hand side equals 12 minus 5, which is 7 on the right-hand side. So dividing both sides by 13 will give us the answer. And don't always think the answers are going to come out nice. Sometimes they won't. In this case, we ended up with y equals 7/13, which is reduced, therefore the answer. Okay, so make sure, you know, if there had been common numbers here we could have reduced, we went ahead and reduced this. But in this case, there was nothing to reduce, so we'll leave that alone. So try this one at home next. I mean, what you're going to do here first is distribute. See, I've got some distributive action going on here, so we'll distribute that through and have 6 minus 12x plus 20 equals negative 2x plus 14 plus 3. See if you can get it from there. All right, in closing, practice the algebra concepts presented to master each lesson. Keep your work organized with problems copied and steps shown in detail. Read related materials in your textbook. Work through similar examples and write down any key points to solidify your understanding. No one can do it for you, so take the initiative. It will pay dividends. Take care, and we'll see you next time.